what is the output of this Python code that is trying to highlight the operator precedence in Python and its importance? When we run this code, is it going to generate an error, or is it going to, after we run the print that depends on variable x, which is defined here, that relies in this assignment or declaration, which one of these outputs is going to be generated? So to evaluate that, let's take a look at the first. Let's take a look at the first line here. So the first line of code defines x, in which we can see that there are a number of operators involved. So we have bitwise OR, we have exponentiation, and then we have bitwise shift to right, we have bitwise shift to left, we have another exponentiation, and then we have XOR. So there, unfortunately, parentheses are not defined here, so we need to rely on operator precedence or precedence of operators in Python. So to understand that, we need to notice that exponentiation has the highest precedence among these guys. After that, the addition and the multiplication are the ones that are the most important after that. So let's say multiplication, then addition or subtraction. And after that, it would be bitwise shift left or right. And after that is XOR, and after that is finally OR. So we have to follow this operation or operator precedence in order to properly execute what this declaration is. So when we look at this, it means we have to first deal with the exponentiation here. So first, there are parentheses like this. So there are parentheses like this that we have to deal with them. So 0 to the power 0 is 1. So basically x is 2 or 1 bitwise shift, 0 bitwise shift. Again, 0 to the power 0 is 1. So 1. And then exclusive or 2. So in this operation, according to this operator precedence, it means that we have to first deal with the bitwise shift. And in that process, the precedence is from left to right. So we have to first deal with this portion, which means it is trying to shift 1 0 bit. So it means it doesn't change anything. So the outcome of this is 1. Next step, we can see that what we are doing is, so the outcome of 1 bitwise shift to right by 0 bit is of course 1. Now the next step is this portion, which means we are trying to take 1 and do the bitwise shift to right by 1 bit. So 1 becomes 1 0 because we shifted 1 bit. As a result, it becomes 2. So therefore, this whole thing says x is equal to 2 or 2 exclusive or 2. Now, in this process, according to what we know, exclusive or has higher precedence than or. So we have to execute this portion. Anything exclusive or with itself, in this case, let's say bitwise exclusive or, so 1 0 exclusive or 1 0. So 1 1 and exclusive or with 1 and 0 exclusive or with 0. Of course, it generates, so it becomes 0 0, which translates to 0 decimal. So effectively, the outcome of this becomes 2 or 0, which obviously in bitwise OR becomes just 2. So therefore, the first line result in declaration or assignment the value of 2 equal to 1, so x equal to declared. Now, let's move on to the second line. I'm going to change the color. So for the second line, what we are seeing is we are printing 1 plus this whole thing. Again, same sequence as before. In this whole list of, let's say, cascade of operators, the multiplication has the higher precedence, has the highest precedence, so we have to first execute x multiplied by x, which means x to the power 2. So effectively what we are printing x to the power 1 plus x squared, bitwise shift by x, bitwise shift, and x squared plus 1. So in this operation, because of what we see here in terms of operator precedence, 1 plus x squared and x squared plus 1, higher precedence. So we have to first compute, given that x is equal to 2, then 1 plus x squared is 5, and x squared plus 1 is 5. So therefore, this whole thing is effectively equivalent to printing 5 bitwise shift by x is 2, and bitwise shift y5. So we have to execute from left to right. So therefore, this portion is first executed first, which means we are shifting, bitwise shifting by 2-bit 5. So 5 is 101 in binary, and if we shift it 2-bit to right, it means we are basically removing the two LSBs and just leaves us with the MSB, which is 1. So the outcome of 5 2-bit shifted to right is just 1. So therefore, as the last step, we need to process 1 shifted by 5-bit to the left. So that means this one becomes 100,000. So effectively we are inserting 5 zeros in front of 1. And obviously this is a binary representation. In decimal, it becomes equivalent to 32. So the final answer is 32 as the proper answer to this question. I hope that this example illustrates and is able to show the importance of operator precedence in Python in terms of when parentheses are not defined, how we have to deal with and with what sequence we have to calculate and compute the result of logical and bitwise and mathematical operators.